So we finally make it to networking in Linux. Just in case you've been waiting with bated breath to figure out how to set an IP address on Linux, we finally hit it. So looks like there's going to be 3 different ways to do it. In pure Linux amazing fashion, everybody decided that they wanted to do it differently. And this is just something that you're going to keep running into every now and then, which is why we look at 3 different distros in the first place. So let's start at the beginning. And that is, how the heck do you figure out what your IP address is in the first place? So we've got ifconfig, and people swear by this command. And, so do I. It's just baked into my muscle memory. I'm just used to it. There's there's no other command that I have typed more than this one. And it's just simply to figure out what the heck is going on in the background. So ifconfig, right? Let's do that. It's going to show you that. It's going to give you information on your IP address. It's going to let you know what your subnet mask is. It's going to show you what your broadcast ID is, your IPv6 address if you have one, the CIDR notation or prefix that it has, your MAC addressing information. It's going to show you how many packets you have received, how many errors, how many packets were dropped for any reason, and different kind of issues that you might have run into. Then how many packets I've transmitted, and then just the same basic information, right? And collisions, you should never see anything here, ever. Well, you should really never see anything in the error section at all, but if there is, you might want to take a look at that. But that's what ifconfig is going to give you. One of the other things that you'll find out pretty quickly is that ifconfig is deprecated. That is a word that you'll probably hear a bunch. And what it means is that it doesn't exist a lot of times in other distributions. Ubuntu tries to make things as easy as they possibly can. And one of the ways that they try to do that is they hang on to some older commands for a little longer than some of the other distributions. OpenSUSE and CentOS have just thrown it away in their latest editions. So ifconfig just doesn't work. You can install it, but a lot of times you just don't want to. What you really want to do is just become familiarized with the new way of doing things. And that new way is the IP command. So IPA is the easiest way to figure that stuff out. And it gives you similar information. So this is really just going to give you the IP addressing information on any given interface. So you'll see I have a loopback. Everything has a loopback. Everybody has a loopback. And this is really just a place, a network interface, a virtual network interface that you can use to, check and see if your network stack is running. And in some of the interesting ways to deal with firewalling, you can route information to this loopback address. So you do the same thing in your Cisco classes. So you are going to run into the situation where you're going to need to dump out information to a specific interface because you don't want to actually route it. The book actually mentions a scenario where you're getting DDoS from a specific IP address. This doesn't really work in the real world anymore, but it's just an example that they gave. So you're getting DDoS by a specific IP address, and you no longer want to process those packets anymore. So instead, you'll use a IP route command to tell it to route any information from that IP address to your loopback. And so it'll never actually get processed by anything. It'll just get black cold. And Cisco calls it that as well. So anyway, just a quick aside on the loopback address. And then you have your actual interface, which it'll give you some similar information, right? It'll give you your MAC address, your broadcast address, which is an odd way to... Oh, that's your broadcast MAC address, isn't it? Sure enough. How weird. Your actual internet address or INET address. So same IP address that you would have seen in ifconfig. in this particular scenario, your broadcast ID, and that's pretty much it, right? And you get the same thing, IPv6. So to compare, you'll see same IP address as above, same IP address as above. One thing that you can do, it really doesn't work that well in Ubuntu, and to be honest with you, the purple that they use in the defaults for pretty much every single time you run this is actually kind of bad. But if you prefer, you can colorize it with -C to help you see some of this stuff. Sometimes it makes it a little bit easier. It draws my eye to it, so I tend to use it. But anyway, if all you're doing is looking for an IP address, this is the way you want to do it. Works pretty well. So, if you ever need an IP address, need to get an IP address, as in you plugged in, DHCP server was down or wasn't working or something like that, and you just need to refresh it, you can use the pump command. You'll need to know your interface name, which you can figure out from, in Ubuntu, you can figure that out from ifconfig because it exists, but you might as well just remember IPA to figure out what your interface name actually is. Then you can type in pump-i and in that interface, and it will basically try to reinitialize a new lease. Notice OpenSUSE calls it differently. For fun, we'll colorize it. Has a different name for it. So you have to be aware of that. Do figure out what your interface name is before you start running these commands. Otherwise, it'll say something like, cannot find this interface or something like that. DH Client can do the same thing. DH Client, I tend to use DH Client more often. So the funny thing about DH Client, though, is that you have to wake it up. I don't know why this is. But running sudo DH Client first will actually wake the thing up. Then you can release your IP address. And then run it again to get a new IP address. And you can see there, went from 6 to 7. That's just one of those things. If you ever need to do this. This is the same as in Windows, right? You have your ipconfig/release, ipconfig/renew. That's really what this DH client process is actually doing. Release, that -R for release. And then DH client again to just reinitialize the service itself, and it'll pull an IP address. So one of the things that you're going to find out pretty quickly, though, is that ifconfig or IPA don't give you all the information, right? If you do an ipconfig/all in Windows, you get all the things that you ever want to know right at the top, or, essentially you just scroll a little bit and you can find everything that you need, right? You can find your IP address, you can find your gateway, you can find your DNS, you can find everything. Anything that you want can all be listed there. Well, Linux has this modular nature to it, where one specific command gives you one specific chunk of information, right? ifconfig gives you interface statistics. Your gateway is not part of that, right? Because your gateway is part of the routing table, not part of the interface itself. You can have 3 different interfaces using the same gateway. So that gives you kind of gives you an idea as to why it's not part of the ifconfig command. Now IP, same here. You're just looking for interfaces. IP, I forget what the actual long command is, but it's like IP address show or something like that. Yeah. That's it. So IPA is actually just short for IP address show. So you're literally asking IP address. Show it to me. Give me the IP addressing information about this specific machine or these specific interfaces, right? So what do? You check out other commands. Netstat R is going to give you an idea, or the route command. It's going to give you similar information. So if you want to figure that out, this is one of the ways that you do that. DNS, let me see. We'll run it here too. Oh, there's no netstat here. So, oh, wow. There it is. And then there's IP route. So this seems to be the most reliable way to do it. So IP route. There it is. Default via. We'll add that to it. There we go. So anyway, it'll actually define it for you right there. Anyway, DNS, and this is going to be another one of those where things are different everywhere. So the etsyresolve.conf tends to have it for you. So see if that's true. Not really. It's just set there. Okay, this one's actually set. All right, so Ubuntu doesn't actually keep it there. So we'll have to go and take a look and see where Ubuntu actually stores it. But it's not really going to be that big of a deal because I'm going to show you how to figure out all this stuff in the kind of that Windows fashion I was talking about a second ago. So don't sweat that. Local name resolution, just in case. This is a file. If you want to manually set DNS resolution, right? So like you know that 10.20.30.10 is named Ashley or something, right? So you want to ping Ashley. You don't have to actually ask DNS for that. You can set that here in Etsy hosts, and you can see this is myself, 127.0. Anything that starts with 127 is going to be localhost, so we are just setting up. 127.0.0.1 is localhost. 127.0.1.1 is ubuserve, which is the name of my server. You give yourself that host name this way. And if you wanted to add anything else, so let's say we had 10.20.30. Let me see, sudo nano Etsy hosts. We can come down here and say 10.20.30.10 is Ashley. Command O. Yep. Command X. Cool. So that should do it for us. Now anytime we try to resolve 10.20.30.10 or we try to resolve Ashley, it'll work. That will resolve it for us. So this is just a manual way to do it. If you don't have it set in your DNS server, but you do have it set here, it will still resolve just fine. This is the way that I was talking about a little while ago. So nmcli dev show is going to give you all that information that I was talking about before. So you have IP address. Oh, wow, I still got both. I need to restart the networking service. You have your gateway. That's what we were looking at before. And, oh, this might be why it's not there. I don't have DNS. How weird is that? But I should. Yes. Huh, that is really weird. Ubuntu is just acting up today, I guess. Yeah, go look at that. It's here. How funny. It's just not liking me today. We'll do that while we wait. All right. So, static IP addressing. So this is the way that what we talked about just a second ago is how you figure out the information that you do have at this moment. If you do not, want a dynamic IP address, but you want to static it, or you want to actually just assign it yourself, this is the way that you're going to do it. So this is just informational. None of the devices that you're running on right now will actually do this, will actually work this way. But you may encounter systems in your career that do. So Ubuntu 16.04, Debian 8, Debian 9, and a lot of those derivatives that come off of those work like this. They have an Etsy network interfaces file, and inside that file, they configure their devices like so, right? So this is a comment, the blue stuff, so is comment. Auto loopback, basically auto means to bring it up automatically, loopback, and then you want to define it, right? It's an interface, its name is loopback, you give it an internet or an Ethernet address, and you're telling it we're going to deal with this as a loopback. So if you want it set dynamically, you'll set, automatically, yes. You're going to define the name here, and then you're going to tell it how you want to deal with it, right? Interface, that interface name, I want it to get an internet address via DHCP. So that's the easiest way to do it, right? Just get it from the DHCP server, I don't care, whatever. But if you're setting any of this up statically, you're going to want to set it up automatically, bring it up, name it that, call it, internet address static, and then you just go define what you want. You don't have to have all of this, by the way. You don't have to have network, you don't have to have broadcast, but you do have to have the other 4 bits as long as you want to get on the internet, right? So your address is defined like this, address, whatever your address is, netmask, whatever you want your netmask to be. Like I said, network and broadcast, not absolutely necessary. The service will figure it out. But if you want it to just be there, it's just good to define it. Gateway and DNS. No commas or nothing, just space in between each DNS that you want to be using and in what order. That's it. Save that file. Restart your network service. So I think in OpenSUSE it's network, in CentOS it's networking. So be aware. I mean, while I'm here, I'll double check on that. Well, in a sec. All right. So anytime you make any changes to this file, the Etsy Network Interfaces file, and same goes with this that we're going to talk about here with the Red Hat and OpenSUSE, you're going to want to restart the network service. Let me see. If it's network or networking. I always forget. Tab. Network. Looks like network. There it is. No, networking. So this is funny because Ubuntu calls it networking and OpenSUSE calls it network. So, oh my gosh, I hit tab way too many times apparently. But just be aware that it's one or the other, and this might actually be why I forget which one it is all the time because it's different in different ones. So, OpenSUSE is network. I believe Ubuntu and CentOS are networking. I mean, Ubuntu is obviously networking, but I believe CentOS is that way as well. And the Mac is just going super crazy, so I don't want to open up another VM just to check. So if you're doing it in CentOS, double check whether it's network or networking before you hit enter. I mean, I guess it doesn't really matter. It'll tell you that's not it when you get there. So we can actually look at this in real time. But it's not going to be this cool looking because it's all going to be set to dynamic stuff. So when you're dealing with CentOS or OpenSUSE, you're going to have to know the name of your interface before you actually get in and do this. Let me see real quick before we go on. Yeah, I still don't have DNS. How weird is that? But it does still have just my one IP. That is so odd. I know I'm getting off on a tangent now, but... Oh, you know what it is? It's because I installed the GUI after the fact. It's set to the server. Where's networking? Network. That's how often. Oh, Yeah. That makes sense. Oops. But then it should be in the resolve.conf. How weird is that? All right, well, I'll figure this out here in just a little bit. Let you guys know what the heck's going on, because you guys are going to run into this too. All right, so let's get that done real quick. So anyway, in the sysconfig network scripts folder, so you can get there. You can do this all in one go if you just want to like nano that file or cat that file, or you can just go there. Oh wow. Oops. And this is a little different in OpenSUSE. That is a slash in OpenSUSE. Oops. There we go. For OpenSUSE. Oops, I don't know what I'm doing. Etsy sysconfig network slash scripts. Okay, I totally did this the other day. Now what the heck's going on? Of course. It'll just all fall down right here. Let me see. Lucky for me. Well, lucky for everyone, I guess. They're going to test you more on CentOS than they are on OpenSUSE. But I have no choice. I've got to open it up. Now, I know a lot of times when you're running on an OpenSUSE server, they expect you to have a GUI. That's an old one. Yeah. Oh, you just need to make the file. So it's not there already? Here we go. It's a little newer. So the reason, by the way, that I don't have this is because it's not even in the book. Which is why I know it's not that big of a deal. There, statically. Yeah, see, and this tells you how to do it in the GUI. So I guess they just assume that you have a GUI. There it is. So it really is that. But they do have a slash there still. Yeah, okay. So if you want it static, you just create the file. So it is the way that I was thinking it. Whoops. I knew I wasn't crazy. It's 0 with your... Well, sorry for the tangent, but... And it may not be important to the test, but it's important to me. Anyhow. There we go. And since I got CentOS open, I might as well show you. Ugh. I don't know about you guys, but I hate running CentOS because the GUI is so annoying. All right, Well, why that does its thing. We'll come back to it. Anyhow, either way, in CentOS, it's going to be network dash scripts. In OpenSUSE, it's going to be network slash scripts. Now, CentOS still uses this format. They already have this file created for you. Well, depending on the name of your interface, right? So do an IPA, figure out what your interface name is, and that's going to be the name of the file right back here. And it's going to look like this. It's going to tell you the type, Ethernet, and then it's just going to have all of this stuff set. You don't need all of this stuff. And some of this stuff will actually be created for you after you reboot or after you restart the networking service. But the primary stuff that you're going to need: boot proto, static, IP adder, netmask, gateway, and then instead of doing like a comma separated value or spaces or something like that, you just DNS1 this, DNS2 this, and then IPv4 failure fatal. This line is actually kind of important. You want to put this down to no. Well, I guess it kind of depends. If you want this machine to boot up, and then if for some reason it can't set this IP address or whatever reason it can't get an IP address on its interface, it is not fatal. It won't halt the boot. Now, if the only thing that you can do with this server is remotely connect to it, right, like you're a million miles away from it, then, I mean, yeah, it's not really going to matter how you set this up. But you're going to run into this situation where if you need an IP address and you don't want it to boot without one, you'll set this to yes. If it fails to get an IPv4 address, it is fatal. Anyhow, you can skip all the IPv6 stuff if you are not configuring IPv6. You do have to have the name of the interface. Same as device. And then on boot. Do you want it to boot? Or do you want it to turn on while you're booting? So that's pretty much it. Where's CentOS? Man, I really wish this VM would remember my display settings as well. Can't get it to do that either. Ugh, and it's just so slow. I do prefer the other ones, man. Like, by a lot. Oh, that is painful. Well, I probably shouldn't do that. Okay, so see, cat etsy sys config network scripts. Yeah, it really was. That's not a typo at all. They totally use a dash there, and OpenSUSE does not. How crazy. So if you do IFCFG or just IF and tab, it'll fill out the rest of it for you. And then if you look at it, that's pretty much how it's set, right? But here, boot proto is DHCP. So basically what you will do is come in here and swap that to static and then define IP adder, netmask, gateway, and DNS. And that'll pretty much be it, really. That's all you got to do. Restart your networking service and this will, it'll show up correctly. As easy as your PZ can be. And then in OpenSUSE, you have to go create that file. But, yeah, the slash, it's going to kill you every time. Kills me. It's really hard to remember to do that. Anyway, swap that, why don't we? Cool. Yep, and there's a screenshot of what the DHCP looks like, so you're good there. Yep, network or networking, depending on the system. Let me see. System CTL restart. What? Now that is weird too. Man, these machines are going to be the death of me, man. Huh. Either way, I know that's how it's supposed to be. So hang on a bit and I'll come back to that one as well. So anyway, if you need to set a manual gateway, route add, default gateway, and then whatever IP address you want it to be. Just in case you do that. So in Ubuntu, here's the deal. Ubuntu's got to be special. They use a totally separate way to configure IP addresses, and that's going to be in the etc netplan directory. And it's going to be what it doesn't actually matter what the name of the file is. It's going to be in netplan. It could be 01, and I don't know, you could say interfaces or something like that. You can create that file and then .yaml and set up all of your IP addressing in there. It does not matter, but when you install the server, it will originally create this file. So 50-cloud-init. It's got that number in the front because it is they expect you to have multiple files in here sometimes, and this is the order that they want them to be processed in. So 01, if you create an 01 file, will be processed before 50. So it's just a way to maintain order in here. So if we wanted, we can go in here. Oop, did I type that right? Nope, mistyped it. We can come in here and configure all of this. So instead of DHCP4 true, do false there. Oop. Now, here's the thing. These files are created in YAML. So YAML is basically a language that is fairly easy to write. It's very English-like, I mean, as you can see. But it's got to be spaced out right. That is one of the big things here. It's got to be spaced out right. So if you are in a situation where you're having to deal with the YAML, use spaces. Tabs will throw you off. By default, in Nano, tabs do 8 spaces. YAML expects a tab to be 4 spaces. So, yeah, just use spaces. So, in this case, we're dealing with just setting the same stuff that we were setting earlier, but we've got to just type it all out. Addresses. You can put the address right next to it, 1010, but a lot of times Ubuntu will create them like this. So this is fine. The reason that you want them like this is if you have a list of things. So your address is going to be that with that subnet mask, gateway, and gateway 4 versus gateway 6, right? IPv4 versus IPv6, 10.10.51. And I'm just using the values that are on the left-hand side there. You'll use whatever you actually want to use. But you can set the address the same way, just like this. So it can be like this, or it can be like this. Either or. But it's got to be spaced out correctly. 1 space in between this dash. 1 space in between any kind of colon or anything like that. And 4 spaces to represent a tab. So that'd be 4 spaces. That's 8 spaces. That's 12 spaces. And then you just continue on down the line with all the information that you want and leave everything else alone. Save that. I'm going to not. And you'll want to sudo netplan apply. And that will set any IP addressing that you've set in that netplan file and just work from there. Oop, whoa. Ah. Oh, man. All right. So that is the file that you're probably going to be dealing with. But just in case, just look in this directory to see if maybe the file name is different. All right, and then don't forget your netplan apply. All right. So here are just some tools. I'm going to show you how they work. Well, yeah, I'm going to show you how they work. We'll do it all in OpenSUSE. All right. So well, I can't show you ifconfig A. Remember, ifconfig is deprecated. Ubuntu is the only one that has it. So IPA will be the way that you want to deal with that. All right, just like that. Same basic information. Now, I kind of have this in a weird order. Let me fix that. Let's do get int first. All right. So, there we go. So get int hosts will essentially give you the order in which you will be asking questions. So, oh, I'm sorry. This is going to show you any of the names that are configured up on your system. So you'll know what you can actually resolve locally without DNS's help. This is what lives in the Etsy hosts file. So that's an easy way to check your host file. So for things that aren't, you'll need to use one of these commands. So host, dig, ns lookup are all commands that will query DNS servers. It will check your host's file, but all three of those commands. It will check your host's file first, but it will then, if it can't find it in your host file, it will then move on to your DNS servers. So name.com in all of these situations is a domain name. So it can be anything. Microsoft.com, technet.com, whatever, youtube.com, doesn't matter. So if you do, it's going to give you DNS information on youtube.com. Dig will do the same. Be slightly different though. So host will give you all the different kinds of hosts that you might want to know about. IPv4, its IPv6 address is that. Its mailer addresses are that. Dig tends to follow a slightly different default. So it will give you the actual DNS record. So the cool thing about Dig is that this right here, right there, that is essentially the exact way that the record is put together. So that's what you sent. That's what you received. If you were to go and configure bind 9, which is what I'll have you guys do in next semester, that line is going to become pretty important to you because that's exactly the way, minus the size here, that's exactly the way that you're going to put it in as a record. So if we wanted to be able to resolve that Ashley name I was resolving before, and we wanted to create it as a forward lookup, you would type in Ashley here, in A, and then the IP address for the Ashley device. So, yep, Dig is as close to the actual DNS record that you can get. NSLookup is available to you guys on Windows as well, so you may already be familiar with this one. And it gives you the same basic information. Right, there's its address, IPv4, and IPv6, depending on the way that your ISP is going to route you out. Now, who is just another command that you can use to query a domain name, but you're not asking for its IP address specifically, you are asking for ownership information. Oh. Let's see if it's available to me. Ah, of course. All right, we'll come back to that one. Let me see. Let me just see if I can do it here. Oh. was totally hoping I could do this real fast. Who will win? Oh, looks like Ubuntu will win. So who is youtube.com? There you go. So this is the information that ICANN has on your domain name. So you can see domain name, you can see who it's registered by, the domain ID, the server that is telling you this information, when it was updated, when it was created, 2005, February 15th. That's when YouTube came online, or at least this domain name at this place came online. Information about it, right? Its name servers, where you would ask where youtube.com lives, and then there's a bunch of additional information that you might want to have, right? So if you're curious about a specific domain, you want to know who owns it, or just information about it, you can use the whois command. And then, of course, we'll skip that. All right, traceroute. So traceroute's a really nice command that can help you troubleshoot maybe latency issues. Sudo traceroute. Oh, and this is because I'm double natted. Yeah, it's just gonna die. So the reason it's gonna die like this is because I am double natted, meaning my VMs are behind a router that is sending information to another private IP addressed router, meaning my home one, and then from there we get out to the internet. So because of that, it's just gonna stall. And traceroute will only do you 30 hops unless you specify otherwise. So actually here, do this. Yeah. I think this will work. Still no? This might be an ISP thing. Oh, there it goes. There it goes. Okay. It just didn't like that first hop after my router. So the only thing that this actually means right here is that the person that I was asking, the next hop, just didn't respond. And that's fine. It's not necessarily showing you that something's broken. It's just whoever that router is isn't responding. I would assume it's a Suddenlink router and it just doesn't like to respond to traceroute requests. But everybody else does. And then you can get this idea that I pinged every one of them 3 different times and they came back with this latency here, 20 milliseconds, 20 milliseconds, 24 milliseconds, et cetera, right? So where does YouTube live? So you can look at that first 3 set of letters there and figure that out. DFW. So, and it turns out this is the way that Google does things. They have basically caching servers at major ISPs or major endpoints, and there's one of them in Dallas. So you only have to go to Dallas as far as internet connection wise to get YouTube. Yay. How close. Anyway, so that you might run into that if you're running on a VM. If you're bridging your adapter, though, you won't run into that. All right, so Netstat. Used essentially to find a lot of different stuff, right? Netstat will basically show you the status of your networking, I guess the whole networking stack. So one of the ones that, STAT, that I use a lot of times in Linux that does not work in Windows. You cannot do this in Windows. Oh, man. Seriously? See if that goes a little faster this time, though. Oh, what? There's no Netstat. Fine. Okay. All right. So, Netstat L will basically just show you listening ports. So you can see that's all I'm listening on, which is not really a whole lot. Oh, and you can see that I'm not running SSH. You would see SSH in here. So let me see. Sudo apt install open SSH server. Let's install that. Good, because I'm going to need that here in a minute when I show you Nmap. Try that again. There it is. So you can see. So basically, if you see anything in these two columns, your network interface is overloaded. It's a queue. So receive queue, send queue, like it's waiting to receive or send packets. So you shouldn't really ever see anything in those two columns, unless maybe like it's an internet server and people are just, you know, trashing the thing all over the place. So what this is saying is any IP address on the local machine. So 0000, if you ever see that, it is basically only listening, or it is listening on every interface on the entire machine. If you want to bind it to a specific IP address or something like that, then obviously that will show the specific IP. So if you have like 3 network interfaces, all 3 of them on different networks, but only one of them is listening for SSH connections, then that's where you'll see this IP address show up like that. Then SSH, it's shorthand actually. It's port 22, but Netstat tries to make this easy for you. And, you know, if you don't remember 22, but you know what the SSH protocol is, then you'll see that instead. I know there's a way to get Netstat to not do these, not do that. I forget how to do that. No one's going to test you on that, so it doesn't really matter if you know that. Let me see. Don't resolve numeric ports. Okay. So -- numeric ports. Yeah, there you go. 22, 631, 53. So these here, only looking on localhost. So these are not exposed, are not necessarily exposed out to anybody else. So this is where it would, where it's actually looking. So on over IPv6, that's how you identify any IP address over IPv6, and still on port 22. So I'm listening on both IPv4 and IPv6 here. And same with 631, there's IPP, Internet Printing Protocol. And then over UDP, I'm listening on these ports here. So UDP6 on that one. All right. SS is another command that you can use to do this. Same basic stuff, but I like SS a little bit better because I don't have to scroll back up. It dumps it down at the bottom, the stuff that I would actually care about. And then it shows you here, these are the only actual ports that are actively listening right now. Oop, no, other way. I don't know how to do this. Mac mouse, man. Where was I? Netstat. There we go. So, -T, well, just use the help, to be honest. And you can find probably all of these. Oh, wow, you don't see T. No wonder I wrote them down. There we go. S for statistics. Netstat L, active and listening. Oh, yeah, that's what I just did. Netstat A will show everything. And then Netstat T will show current TCP connections. So Netstat T. And there's nothing. So if someone were connected to me, oh, yeah, that's why you want this one. If someone were connected to me, then, so like if there was an active SSH connection, we can actually come back and look at this here in just a minute. If there's an active SSH connection to me, you will see that connection shown down below. Let's see if we can do that, actually. What's the IP address here? See what I mean? Muscle memory, man. I can't ever remember to do IPA. 10.20.36. Yay. Let's see if that is true. There we go. So the foreign address is 10.20.34. The port I'm using to connect, the random port that I'm using to connect from the OpenSUSE Box is 53692, and it is established. So, hooray! So that does actually do what I'd mentioned. Just shows current connections. Ping and traceroute, I mean, you've used ping a bajillion times. But in Linux, if you do ping, you have to kill it with Control-C. It does not stop unless you specify how many times you wanted it to ping in the first place. I think you do that with T... it's C. No, it's C. Yeah, count. So unless you do ping-C like 5, it won't stop. So this will do 5 counts. Done. But if you just do, it will never stop. It will just keep going forever and ever and ever and ever and ever. So Control-C will break you out of that. Windows is the opposite, right? Like if you want it to go forever, you have to actually specify, I think it's -T in Windows, to specify like never stop. In Linux, it's the opposite way. It will never stop unless you specify how many times you want it to have gone. So Control-C will break you out of that. TCP dump. This is the most fantastic utility ever if you ever want to figure out what the heck is going on your entire machine. It's actually fairly simple to get started. The hard part about TCP dump is actually reading what you're dealing with. So, TCP dump. I don't think it's installed. Oh, sure enough it is. So, sudo TCP dump. You want to write a dump file. Well, let me see. I think you just do it actively, right? Yeah, it'll just go active like this. And this is just pretty much everything that I'm being that I'm connected to, that I'm doing. And then I bet you can see. Yeah, look at that. Every single thing that I send, it's sending packets. And then obviously we'll do ns lookup. Let's see if I can get it done. Let's see if there it is. You can see the quad A record that I got. There's the A record there. There it is. There's my my query. Answer for youtube.com. Answer is that. So it's a little easier when you're not over SSH, but you can see that it's like, this is SSH, this is SSH, this is a packet from SSH, this is SSH. So if I were doing it locally, it'd be a little cleaner than that, which is why you want to do a dump a lot of times. So let me get out of there. And we'll do this. So then sudo TCP dump, write a file, and we're going to call this one packet.cap. These files tend to be .cap files or .pcap files. TCP dump tends to like cap, or well, you'll just see it pretty much written like .cap all the time. So packet.cap, and that W stands for write. And then whatever you do, oop, I don't know why I opened that. Wait for it. You'll probably see some packets. Oh, actually, it's not. It's not showing me what's happening, I don't think. So let's see. We'll go there. Okay, Control C to stop that. And you can see there's a ton of packets, right? All that SSH stuff I was doing, 278 packets. You go to one website, and the amount of packets tenfold, almost tenfold. So anyway, if you want to read one, read packet.cap. Oop, sudo that. And you can see all this junk. right? Tons and tons and tons and tons of junk. Well, what you really want to do with all of this stuff is actually just sort it. One of the things that you can do, I've got an example of it over here, I believe, is your destination port. You can sort by that. And then so let's do destination port 53. And 53 being DNS. These are all, check this out. I mean, just so you know, starting about here. These are all of the different queries that you make when you go to YouTube. Oh, wow, I'm still resolving some Mozilla stuff. But yeah, you open up Firefox and then you go to YouTube. These are all of the different domain names that you go to. You ever wonder why your battery life is so bad once you connect up to Wi-Fi? It's this right here. It does not matter what browser you use either. It is pretty bad. But, you know, whether it's IPv6 with the quad A or IPv4 with the single A, you're resolving name after name after name after name after name. It is crazy. Anyway, so you can sort any kind of protocol like that if you want. 443. Those are all the HTTPS packets that I'm dealing with. Tons and tons and tons and tons and tons. I mean, there's 5,000, right? Total packets on that whole thing. So obviously HTTPS is going to be the bulk of it because that's this, right? All of that junk. All right, so I don't need you guys to be experts on TCP dump or Wireshark or packet captures or any of that stuff. I just need to know you. I just need you to know how to do some basic things like do a packet capture, name it whatever, read the packet capture, and filter on the packet capture. That's pretty much it. Those three things. You can do those three things, you're good. So NMTUI, pretty fantastic. I don't know if this one has it. Sure enough, does. NMTUI is pretty fantastic. It is a network manager text-based user interface. So you know all that stuff I showed you before about how to go and actually configure an IP address? Well, if you have NMTUI, you don't have to remember any of that. For the test, you will have to remember those things. For dealing with an actual server in production, nah, you don't have to. This works over SSH as well. So long as you are not configuring the IP address of the interface that you are SSHing in on, you can do this as much as you want to. So edit a connection, wired connection 1. Here, let me scoot that over a little bit so you can see. You can see, oh, there we go. See what kind of information it has. You can add an address, add a gateway if you want, add DNS servers, all that fun stuff. Super duper easy to configure this stuff. Setup manual. And you want to go in and configure all of that, however you want to do it. So it is really nice. Cancel all that. Back out. You can turn on a connection if it's off this way, and you can change your host name from inside of here. And that'll do it. NMTUI, pretty fantastic. I think it exists everywhere. Let me see if we can do it here. Yep, sure enough. So, and I know CentOS does have it. So it works in all the OSs. That makes things so nice. NMCLI dev show, NMCLI. If you can do NMCLI, you can do NMTUI. Those two things are from the same family. ARP, pretty little fantastic tool. Any machine that you've connected to or have probed or is talking on the network or something like that, you have a record of it in MAC addressing. And this is just ARP is just going to show you, the command ARP is just going to show you your MAC address associations. So I know about this MAC address. It is associated to this IP address. I can communicate to it. So Nmap. This is a pretty cool tool. So Nmap stands for Network Map. Oh, cool. It's already in there. So Network Map does exactly that. You tell it a network or an IP address to connect to, and it will map everything out for you. So if we do, let's see, my gateway is 10.10.10.20.31. So let's do Nmap. There. So you can see I did a scan on it. Here's the report for that IP address. It is up. 999 out of the common 1,000 ports are closed. The one that is open is this one. So I've got 10.50.10. Let's do it for that. This is my device, by the way. Never do Nmap on a device that you do not own. And you can see SSH is open up on it. It services DNS requests, and there's a web interface. So this is the thing, right? This is why Nmap is so useful. HTTP is open, which means I can crack open Firefox and go to that IP and see stuff. So this is my Pi-hole, actually. It's a really nifty little device. It'll block a lot of ads for you. It doesn't get them all, but it does block a lot, which is really, really useful. You know, on devices like if you have an iPhone or something like that, you can't install ad blockers. It's just not a thing that you can do. Oh, here. And then you can kind of see, you know, here's the stuff that's been blocked, how many domains are on the block list, how much of my traffic has been blocked, how many actual queries there are that have been blocked, and then total queries that are happening right now. And look at that. I mean, I don't know if anybody's actually using the internet right now, but I'm sure they are. But there you go. Look at that. Like, it just DNS queries all day long. It's crazy the amount that happens. Hey, I need to go update. Cool. I'll go update later today. So pretty fantastic, right? But that's what told me. Nmap told me that that device has that on it. Let me see if I can do another one. 10.504. I think 4 is special on my network. Y'all won't have these devices, by the way. This is my stuff. I'll let that run in the background. But you can scan other machines as well. Your other, if I were to do the Ubuntu, if I were to scan it, you'd probably only see SSH. I did install that, and that's up. So, NC, Netcat. Netcat is pretty awesome. It can do a few different things. It can connect up to other machines on specific ports to see what kind of things that machine might say. So if you wanted to see Netcat connect up to port 22 on that IP address, so you can see Netcat, the remote IP address, the port you want to connect on, and just see what it says. That's all Netcat does. It doesn't actually try and initiate a real connection or try to send a password or anything like that. It just pokes it on that port just to see what happens. And then when that service responds back, Netcat will tell you what's going on. If you want to have Netcat pretend to open up one of those ports, it won't actually respond. So this is port 22, right? It won't respond like SSH or anything like that, but it'll notice that something tried to connect to it on that port. Yeah, it's going crazy. So, let me see if I can do this. There we go. So, NC listen on port 22. Oops. Oh, that's right. I'm already running SSH on port 22, so I can't do that. There we go. Port 23. And then I do an listen. You should. Yeah, telnet. I'm not actually listening or running Telnet, but Netcat has opened up that port. And so because SS and Netstat does this, port resolution, it will actually just tell me that it's Telnet. So you can do that. Let's see if this is done. Okay, there we go. Yeah, so, the things that live on 10504, SSH is available, but it is closed, it is refusing connections. It's got a port 80 website, it's got a port 443 website, and then it's got another protocol using WebM, but it's closed. So if I were to go to this IP address or that name on my network, I would get a web page. Being sneaky about it, I don't want you to know what's on there. But it has got a web page. I just wanted to show you that's how Nmap will show you stuff. You can do some really sneaky things with Nmap as well. Nmap can basically ping things that are unpingable. So if for some reason you suspect that an IP address is up, but it's not responding to your pings, and it's not responding to your SSH connections, and it's not responding, you can trick it. Well, that's not really a trick. It's actually just the way that that layer 2 networking works. You cannot block an ARP request. It is not blockable. You will break yourself on the network if you try to block ARP requests. So one of the things that Nmap can do is scan an entire network. So notice I have the network ID / the CIDR and this SN. SN is basically a ping scan, but it's a misnomer. It's not actually pinging anything. It's doing an ARP scan, actually. So you can do that, and it will tell you 1, 2, 4, and 6 are up on this network. You can do the same thing with let's see if that'll get back at me. Yeah. You can see all the devices on the network next one hop away from me. Oops. 1, 3, 4, 5, 6, 7, 8, 9, 10, 14, and starting at 100. A few devices up. So Nmap is really informative. So let me just show you. Those are all of the options that you can use with Nmap. Right, there's that ping scan. But like I said, it's a misnomer. It's not actually pinging anything. It's just doing ARP. So anyway, if you want to do a port scan, if you want to know about a specific port, let me see. ifconfig .6 Nmap. You can do port 22 10 20 36, and then it'll tell you, yep, port 22. Oops. Port 22. Open. It's SSH. You can do the same thing with 23. Let me see if it's still running. Yep, still running. Now here's the thing. Once Netcat receives a response or a request on the port that you're listening to, it will close. It does not just indefinitely stay open. So if we do that, so yep, 23, it's open. It's assuming it's Telnet. It's not actually Telnet. It's just Netcat. But you come back over here and look, it closed. So if I were to Nmap it again, it would be closed. Right, so Netcat does not indefinitely stay open. Once you poke it, it turns off. So IFTop, really cool thing. I don't know if it's installed. No, is it? No. IFTop's pretty cool in that it will show you, just like Top and IOTop that we looked at before. IFTop will show you all of the different connections that you've got. And let me see. Oh, there it goes. Oop. Let's do... If we get into Firefox, it'll probably show you some better stuff because it's gonna have a ton of connections. There it goes. So it'll show you how fast. It'll show you what, at least IP addressing wise, you're connected to and what you're doing. So I mean, if you're actually running on Linux or something like that, let me see. This is gonna run horribly, but you can see what's going on. And then this will pretty much be it. So while I'm waiting on that, common ports, these are just ports that you need to know. Those may or may not show up on the test. In the quiz that I've got for you guys, there's one port that's not on this list that is the challenge. I want you to go figure out what that port is. It's just one Google away, so don't sweat it. But it is a port that is used all the time in Linux stuff. I don't need you to know this for any kind of like Linux certification test, but I do need you to know it because it's going to be used a lot. So let me try to do something. There we go. Cool, right? Like the BBC won't show anything horrible, right? There. And you can see now the scale is up to 19.1 megabits. Pretty cool stuff. All right. Well, that's good enough. That's what iftop is. And it shows you down here, by the way, all your stats overall. Q will get you out of that. And that's it. We are done diggity. Oh, I forgot about that file. So when you do getEnt, it reads one specific file. And the file is really just there to have, just to show you the order in what getEnt will do. Cat Etsy in switch.com. So if you're looking at hosts, so I did getEnt hosts earlier. It's going to look at files, which is your host file, blah, blah, blah. Then mdns4, and then DNS, and then it will check your host name at the very end. So this is just a list of things that it will check. In that order. It will be in that order. I forgot to show you that. But that's it. That's all there is. Cool. If you guys have any questions, obviously, just let me know, and we'll figure it out. It's best in Slack in the general channel. That way, since y'all are the biggest group that I've got, if y'all have questions, put them there. That way I can answer it once. Make it a little easier on everybody. Or email me, and then I'll copy your question to the Slack. But anyway, that's all I got for you guys. The lab is awesome. Thanks, Nick. The lab is pretty simple. It's just, it's pretty much the stuff that we did. So, you're going to be setting your IP address, showing me what the IP address is, make sure that you have internet connectivity after that. The whole deal with that is that I need you to go and figure out what the IP addressing stuff is first, and then make sure that you're using the same gateway and DNS and network ID at the end of all of that. Not network ID, but subnet mask at the end of all of that. So for CentOS, I'm having you use TCP dump. I want you to save a capture. Go to Firefox, go to TechNet, and then at the end of all of that, I want you to read that capture and find the query for technet.com, that A record. Remember, DNS is on port 53. That'll help you sort it. Ubuntu similar. Make sure you have internet, and then use Netcat to begin listening on port 40, and then just leave it running. All of these are, by the way, just like I have them. They're on a NAT network. Use that subnet mask, or this network right here. So create a NAT network. For those of you that may not remember how to do that, you just come in here. I know this is on Mac, but you'll just go to File, I think, and then Preferences in Windows. Under Network, create one. I don't care what you name it. but configure it, I want you to have the IP address that I've got in the lab, or the network address that you've got in the lab, and the subnet mask of 25. That is not a typo. Right? 25. And then make sure all your VMs are on it. I skipped that part. So say this VM right here, you can click on network down here. Make sure that it is on that network and that network. Whatever network that you created. A safe bet is just to reboot them all. That might work. That might work the easiest, I mean. And then on OpenSUSE, let me see, connectivity with Dig, ping Ubuntu and CentOS to make sure that you're connected, and then use Nmap to run a port scan between 1 and 1,000. So you'll do the port scan like I showed you earlier, and then to do a range, you just do 1-1000. It's going to do that automatically. It doesn't. You don't actually need to do that. But I do want to see you actually explicitly ask 1 to 1,000. So that -P 1-1000. We'll get that done for you. And then you should be able to get SSH from both. If it doesn't, don't worry too much about it. But what I really want you to see is that port 40 on Ubuntu. I want you to do that netcat thing up here. Listen on port 40, and then the Nmap scan will find that. And then just show me. Take a screenshot of that. All right. If you guys run into issues, let me know. Here's a list of all the things that I want. So there'll be 14 screenshots, blah, blah, blah. Go through all that. Those are in order. So when you're working from top to bottom, they are in that order. But that'll do it. The quiz is pretty much the same way the quiz always is. All right, y'all.